All right, let's get started. Hello, everyone, and welcome to the daily space of September 24th, Monday of 2018. I am your host, Dr. Andres Plazas, and we're going to bring you the daily space. This is a production of CosmoQuest, part of the Astronomical Society of the Pacific. And today we're going to talk about three news related to Origami, the solar system exploration, Hayabusa, and Mars. And actually, before that, this morning I woke up and then somebody said that they had proven the Riemann hypothesis, which is mathematics, not astronomy, but it's very related. Anyhow, maybe later in the week we can talk about that. But for the first story of the day, we're going to talk about how people are starting thinking about using origami to build stuff on Mars, in the moon and Mars. So this is a very interesting idea, very cool. I remember hearing about this the first time back at JPL when they were thinking about using something called the star shade to put it in WFIRST, in the Wide Field Infrared Survey Telescope, in order to block the light from a planet. And these are these structures that fold and they follow the principles of origami. So what's the point? Why do we want to do that? Well, with this first news, this is actually a project. It's a collaboration between something called the International Lunar Exploration Working Group and the European Space Agency and architects, textile architects, one of them called Samira Boone. And they want to incorporate origami structures into digital weaving processes in order to sculpt these complex forms that are very compact to transport and easy to deploy through something that could be inflatable or something that could pop up. And they want to do this in the moon or in Mars, for example. And the idea is that, of course, these structures, they can be unfolded into a myriad of different shapes. They are lightweight, and they can be easily deployed and reused in different configurations and even sizes for flexible spatial usage. So yeah, when you're in the hostile environment of space, for example, there's high performance textiles and the flexibility of origami, it allows you to, it actually creates a unique architectural advantages. So for example, one of the things is like the angle facets of origami, you know, when you have these structures, they're actually not completely flat, but they have these little angle structures. That could mean that if you have an incoming meteorite or micrometeorite, then these particles, these objects are less likely to hit the surface at a 90 degree, like at a perpendicular angle. And that's actually good because it dissipates the energy. If you don't hit at 90 degrees, then you're going to dissipate better the energy of these potential impacts, and of course you're going to diminish the risk of penetration, just providing more protection. And if you have, for example, solar panels that follow this type of architectural structure, they could change their shapes and they could follow the sun in such a way that is more optimal to gather more energy throughout the day. So they have performed initial tests of course, on this type of materials. And in one of the European Space Agency's facilities, actually, they did this in April of these years. And now they're planning a more ambitious series of trials in the next year. That, for example, in 2019, they're going to go to a glacier in Switzerland, and they're even planning to go to a lava tube cave system in Iceland in order to prove the quality and how practical these materials can be actually. And in the future, then the researchers also mentioned that one of the design milestones that they want to reach is to build a self-deployable origami habitat. And yeah, it's just pretty cool. So let's see how it goes. I think it's a pretty neat idea, even as I said, even since I found about the star shade from W first. And I remember actually reading the papers about actually mathematical foundations of origami. You can put it in terms of the vertices and the sides, and then you can create a geometry and write axioms and create all these theorems that, of course, are gonna allow you to figure out what's possible or not. You know, what you can build or not from first principles. So that was our first story for the day, which I thought it was pretty cool. And now moving on, we're gonna talk about Mars. So these are some news coming from Brown University. And this is a new study actually that shows that the breakdown of water molecules that are trapped inside ancient Martian rocks, they are actually likely to produce, the researchers have found that they are likely to produce enough chemical energy to sustain microorganisms for hundreds of millions of years underneath the surface of Mars, of the red planet. So the researchers use calculations like from physics and from chemistry. And they show that it is likely that the Martian subsurface had enough dissolved hydrogen to power like what they call a global subsurface biosphere. So they do, what do they think this could be the case? Because here on Earth, we have this type of microbial ecosystems. They're called slimes, and they're an acronym for subsurface lithotrophic microbial ecosystems. So just call them slimes. They're microbial ecosystems underneath the surface. And because they're underneath the surface, they lack the energy from the sun, of course. So they need to get their energy from peeling off electrons of molecules in their surrounding environments. So, for example, dissolved molecular hydrogen is a great electron donor in this case. And people know that this is a known mechanisms through which these slimes on Earth get their energy. So, coming back to the study, the researchers say that they show actually that if you have a mechanism to break the molecules of water, which in this case is called a radiolysis. Lysis means to split. So this is a process in which radiation breaks water molecules into their constituent hydrogen and oxygen parts. And this mechanism could actually have created plenty of hydrogen in the ancient Martian subsurface. So the researchers estimate that the hydrogen concentrations in the crust around about 4 billion years ago could have been in the range of the concentrations that could sustain the plentiful microbes on Earth today. So what they did, well, this of course doesn't mean that the life actually existed of ancient Mars, no? But as usual, right? We're trying to find conditions that make life more likely to exist and to see even if those conditions could have existed even in the past. All that would be great information to try to figure out. So the researchers actually, they took look at data from the one spacecraft that is flying above Mars, is the NASA's Mars Odyssey spacecraft. They have a gamma ray spectrometer and then try to trace the abundances of radioactive elements such as thorium, potassium, and then try to figure out the traces of other elements, radioactive elements such as uranium. And then these are the elements, the decay of these elements, and then you know the rate at which they decay. Then the decay of these elements, they can provide this energy to produce the radiolysis, and also you can also figure out how long ago these abundances could have existed. So in addition to that, then one last point that the researchers point out in the press release is that they used geothermal and climate models to determine that sweet spot in the surface where potential life could have arisen. So it's another habitable zone, right? So Many times we talk about the habitable zone within a solar system, which is that part for a planet that is not too close to the star or not too far away from the stars, such as water can exist in liquid form. So in this particular case, they try to find this particular zone within the subsurface of Mars, that is a part that is not too cold and not too warm. So you can find more abundance of hydrogen, and then these maybe potential microbes could get energy through this radiolysis process. So yeah, well, so this is very exciting, of course, and it also have implications for future exploration, right? Because then the researchers point out that these findings could be useful in thinking about where to send a future spacecraft that's looking for signs of past Martian life. So one of the interesting points, or one of the interesting things that we could look at of options for exploration, is looking at these chunks of rock that actually were excavated from underground via meteorite impact. So you have these impacts from meteorites, and then you have all this rock that came from the subsurface. And then it could be that many of them would have come from the death of this part of this habitable zone that they found out with their models. And now they're could be just sitting there at the surface in relatively unaltered. So that would be an interesting part, an interesting thing to look at if you're going to think about sending a rover into Mars and to try to figure out where to look at. So yeah, that's the second story of the day, which I also found very interesting. And then finally, even more interesting news, pretty cool. They're pretty cool news, but this is particularly exciting because maybe you have heard but now we have confirmed that the Japanese Aerospace Exploration Agency, or JAXA, they sent this mission called the Hayabusa, or the Falcon. I forgot what it actually meant, Hayabusa. I looked it up. Something with Falcon. Peregrine Falcon, I think. This is the second iteration of the Hayabusa mission, because like 13 years ago they had already tried to deploy something in an asteroid, but unfortunately they failed. But now they have confirmed that this Hayabusa 2 mission has deployed the first of a series of asteroid landers and rovers in the early Friday morning on September 21st. So these are those robots they were built by the University of Aizu in Japan, and they're called the Minerva rovers, Minerva stands for Micro Nano Experimental Robot Vehicle for the asteroid. As usual, astronomers and space people need to make a contrived acronym. But anyhow, after 3.5 years from traveling from the Earth to the asteroid, Hayabusa made it to the asteroid. This is an asteroid that is about 0.6 mile wide. It's not that large. It's about 1 kilometer of diameter. And this is an asteroid called Ryugu, 162173 Ryugu. That stands for, comes from a Japanese word that is Ryugu, which is the castle of the dragon or something like that. But the point is that they deployed these rovers, rover 1A and rover 1B, and they're actually sending pictures from where they are. Actually, this is very remarkable, and if you can see in your screen in the upper lower left part, the first picture, and you can actually see the shade of Hayabusa on the asteroid. It's pretty cool. Looks like a spaceship from Star Wars. And then in the lower right corner, you can see a picture from one of those little rovers that landed and that were actually hopping around the asteroid. So it's pretty cool. And and one of the interesting things is after the release, the rovers were actually on their own. Actually, the researchers say, that there was a period of about 24 hours on Friday where actually they didn't know anything about the pair. So I remember when I was working at JPL, they would show you this video at the museum of what is called the 7 minutes of terror, and you can look it up on YouTube. When they sent something that fell into Mars, and like for 7 minutes they actually had no idea what happened, and then after 7 minutes they figured out, of course, that it had landed, and you can find it on YouTube, and of course it's going to be very dramatic, but it made me think when I was reading this news, like these people were 24 hours, like what happened to the rovers? Are they still working or not? The good thing is that they are, and yeah, this is very, very exciting news. And one of the things, one of the climax of the mission in the future is that in October of this Hayabusa 2 will approach the asteroid, and it will fire a 5-gram tantalum pellet at the surface, and it will attempt to collect a sample for return to the Earth. So if it is successful, the sample collection capsule actually should arrive home in December of 2020, which would be very, very exciting, very cool news. So that's all of what I wanted to say for today. Now let's see if you have any comments, any questions. I'm gonna look at the chat and say hi to everyone, the people I haven't said hi to. Larry, hi Susie, Ed, hello Magnus, Faring, Ironheart, Astro B, hello from London. Honey says, I made a paper swan once. Yeah, I used to make cranes too. And there could be a lot of actually complicated shapes to make, but important that the funny thing is, like, so first I encountered origami, of course, as a kid, and then you learn to do all this stuff, and then it's funny, and then I encountered like a paper on origami, and you can define a geometry of origami with the vortices and the rules, like, you know, the axioms of, for example, Euclidean geometry and the 5 axioms, and that was pretty cool. And then even cooler is that you can actually find engineering applications, and then from the optimal point of view, it makes sense to build the structures like this. So it's very exciting. These are support structures. Some of them are, as I said, some of them, they want to build like a habitable, actually, structure. So that would be pretty cool. High Speed Drag says that my teeth are white. Thank you very much. I'll take that as a compliment. It might actually be an artifact of the light falling onto my teeth. So now you guys are talking about furry things, all right? Pretty cool. Radiolysis, wireless electrolysis. Yes. What else? Will Mars 2020 help with this line of reasoning? What could it test from this? Yeah, one of the researchers actually from Mars 2020 is actually commenting in this paper. And this person says that he's been actually one of the persons active in the process of selecting a landing site for Mars 2020. And he mentions that this type of rocks that come from that excavated rocks that come from meteorite impacts, they're called actually breccia rocks. They're present in at least 2 of the sites that NASA is considering for Mars 2020. So yeah, definitely. Well, the mission of the 2020 rover is to look for signs of life in Mars in the past, and this is definitely this study, of course, shows that this type of areas actually is definitely something to keep in mind, to try to find out these samples of these rocks that came from the underneath the surface, that maybe came from this habitable zone within the surface of Mars. The inside lander is supposed to look at the Martian subsurface to a degree, isn't it? I don't remember actually. So let me look it up. Yeah, to be honest, I don't remember, but yes, actually it is designed to study the interior of the planet Mars. Yeah, that's why they gave the name. Yeah. Was a question by Astro YYZ. Astro YYZ also mentions Ryugu, lens flare. Yes. Hopper, not Robert. Yes, they're hoppers. They're very. Yeah, that's a good point, Larry. They're hoping. And they mentioned that they have like a cool mechanism that actually uses like the torque produced from rotating masses inside the bodies. So yeah, it's pretty cool. It kind of looks like a Canadian flag. I don't know what you're talking about. One of the pictures from Hayabusa, from the hoppers. Maybe, I guess. So Larry's telling us that it takes about 15 minutes to hop on land. I didn't know that, so that's pretty cool information. Thank you. Fenry says, that's not a moon. Yes, in quotes. From Star Wars. Astro YYZ, that was an awesome video for the landing of Curiosity. Yes, that was pretty cool. Oh, I actually also forgot to show this video of Hayabusa. I was actually approaching Ryugu, and it's a composite of several images. I think you can see it now on your screen as it approaches. And that's pretty cool. I always like when they make all these composite images and you can see things in real life. Simple things, like the other day I saw this composite image from like the moons of Jupiter or Saturn from Hubble Space Telescope images, and they show like the movie, and then you can see how they're actually moving in elliptical orbits around the planet. So it's pretty cool. If something was eating that hydrogen all this time, would we be able to see waste products? That's a good question, and I don't know the exact answer, but I would think that if you find something similar, I mean, I would look for this same type of microbes, these slime things that you find on Earth, and then I would study them and see what kind of waste they produce, and then try to figure out if there's something that I could detect with the rovers or the machinery that I have on Mars. The other thing is that these things are going to be underneath, in the subsurface. But then again, if we can get a handle of one of those chunks of what samples that came from an impact of an asteroid and were carved out of the surface, so maybe we could also design an experiment around finding the possible detection of a microbe that would behave in a similar way to these slimes on Earth. The shadow of the satellite looks like a Canadian flag. Oh, okay, maybe. I see that. All right. Japan is harvesting space potatoes, I guess. So, what else? Somebody's asking, do Hayabusa landers carry any scientific instruments, or are they just taking pictures? That's a good question. Let me check. I think I saw. So is one of these hoppers or rovers? Well, they call them rovers, rover 1A and rover 1B. They each carry a thermometer. They carry a wide angle and stereo cameras. They have, of course, their solar panels and also the ability to communicate with the Hayabusa too. So that's pretty much it. These are very like small pieces of equipment. So I think that's about it as far as I can read from the press release. Yeah, it would be interesting to see, but I think it's very limited at the same time. And then at the end, they also, as I mentioned, they are planning to collect a sample to return from the Earth. So that would be interesting to know more a little bit about that, how they're planning to do that. So that would be pretty cool. Are we going to get VR images? That I don't know, but that would be pretty cool. This image that we already look at in the screen in the lower right hand side is already pretty trippy, and yeah, it would be pretty cool if they could actually make all these 3D images or something like that. So yeah, depending on the quality of the instruments and what they can actually download or not, or upload to Hayabusa. So yeah, I didn't read anything formally about getting VR images, but that would be pretty cool. All right, everyone. Do you have any more comments or any more questions? And I just wanted to say just a comment, like I got the chance to meet some of you about a week ago at the Astronomy Cast 500 episode, so it was a lot of fun to see many of you in person, so thank you very much always for showing up. I think this is my first time since that time that I do the daily space. It's been always Dr. Gay who's always here. Anyhow, but if you don't have any more comments or questions, do you have any interesting Larry's telling us about the escape velocity, and as Disillusioned is telling us that the SNES could send you out into orbit of that asteroid. Yes. 0.069 meters per second escape velocity. So yeah. Well, anyhow, as I was saying, so that was the daily space for today. So thank you everyone for watching as usual. And this has been a production of CosmoQuest as part of the Astronomical Society of the Pacific, and we appreciate it very much when you give us likes and when you share and when you subscribe and when you tell other people, hey, this is the daily space, take a look at us. And thank you for showing up, and it's always a lot of fun for me to talk about the stories with you and to comment. And we will be back tomorrow at the usual time, 1 p.m. Eastern Time in the United States. Dr. Gay will be your host, but hopefully I will be again back with you later in the week. So have a wonderful week, and see you later. Okay, bye-bye.